Alright, so in this video, we're going to be preparing our vocabulary and marking the picture for our new unit of congruent triangles. Okay, this will be very, very helpful in proving triangles to be congruent. The first vocabulary word that we're going to talk about is bisecting. Okay, when we're bisecting something, it means we are cutting it in half. Okay, that goes for angles and segments. So when we cut these things in half, okay, we're actually creating two congruent parts. Remember, congruent means equal, okay, for segments and for angles. Okay, we've created two equal parts. So let's look at what some of the wordings might look like for this. So they might say something like MN bisects GH. Okay, so that means we have a line MN and it is bisecting line GH. And when something is bisecting, we've created congruent parts. So they would be marked with these hash marks there. Okay, and I could take this even a step further if I labeled the point there in the middle. Let's label it L. Okay, and we could say that GL was congruent to LH. Okay, that's if something is bisecting there. We could also have things bisecting each other. And if they bisect each other, let's do AB and CD bisect each other. Okay. Here's A and B. C and D. Okay. And if they bisect each other, we're now going to have two sets of congruent pieces. So this piece would be congruent to that piece, and this piece would be congruent to that piece there. And that's through that intersection point. Okay, the number of slashes or hash marks or whatever you would like to call them correlates to which pieces are actually congruent. The last part is if we have an angle, so maybe we have ray AB bisecting angle CAD. Okay, so if we have that, we've got angle CAD. Okay, and then ray AB coming out from it. Congruent marks for angles are going to be little arc marks in the corners. Okay. Now notice that they each have one arc signifying that they are the same. They could have had two, right? They could have three, they could have four, but the marking itself needs to match so that we know that they are congruent. Okay, and we again could take this one step further and we could say that angle CAB is congruent to angle BA, oops, went the wrong way there, is congruent to angle DAB. Okay, now I could not just label it angle A because angle A could be angle CAB, it could be angle BAD, it could be angle CAD. So we have to use three letters here. Okay, the next word is midpoint. Okay, so midpoint is going to be the point that's exactly in the middle of a segment. okay? And it's going to divide that segment into two equal parts, or congruent parts. So it's very similar to bisector, right? So if we have the midpoint of something, maybe it says C is the midpoint of EF. Okay, so I have segment EF, and I have point C that's in the middle. Okay, and if point C is in the middle, I know that EC is going to be congruent to CF. I'm going to write that so we can see what it's implying. Okay, again, the hash marks there are signifying that they are congruent. Okay. Perpendicular. We've talked about this in class multiple times. Okay, perpendicular means you're intersecting to form that right angle. And please remember that the symbol for perpendicular is that upside down T. Okay, and segments that are perpendicular are going to form right angles at their intersection. Okay, they'll form that right angle at the intersection. So it might say that AB is perpendicular to, using the symbol there, CD. Okay, and so from that picture, we could imply that all of those angles are right. Okay, you also might see it in the form of a triangle. Okay, so we might have triangle here, ABC, and D there, and they tell us that line BD is perpendicular to line AC. And if they tell us that, we can assume that those angles at D there are right angles. But only if they tell us that can we assume that. Sometimes we'll look at the picture and we want to assume that. We can't assume that unless they've told us. Okay, that's perpendicular. Next we have parallel. Okay, so anytime we hear parallel, right, those are lines that never intersect. Talked about parallel a lot in here. And the symbol, again, is the two lines. I always think of the symbol as, in the word parallel, it has those double L's. Okay, so when two lines are parallel, we're looking specifically for the alternate interior angles being congruent. And they form that letter Z. Okay, and that's what we're really looking for. So anytime they give you the clue of parallel, you are looking for alternate interior angles being congruent. So the picture we really want to look at is going to be one that looks similar to this. So we know that LM is parallel to NO. Okay, and we have, again, that bow tie shape that we've seen a lot. Okay, and they tell us that this is LM and this is NO. So if we see that, okay, we're looking for alternate interior angles. I'm going to put the arrows here so we know which lines are parallel. Arrows are signifying parallel on our picture for our diagram. Okay, and then I'm looking for where Z's are formed. So here's my parallel lines, right? And I'm going to pick a transversal. So I'm going to pick transversal and M there, right? And so my parallel lines are here at M and here at N. Now we have another transversal in there that we could choose. We could have picked LO as well. And if we picked LO, we would find that angle L here, I'm going to use two arc marks this time, is congruent to angle O. So angle O is congruent to angle L, and angle M is congruent to angle N. Okay, so those are things we're looking for parallel. Then we have vertical, right? We've talked about vertical a lot. These are angles that are across from one another. Okay, and they will always and forever be congruent. Okay, and I like to think of vertical angles as bow ties or that hourglass shape. Okay, they hardly ever tell you that things are vertical. You have to know that they are vertical. Okay, so for us, it's mostly going to look like that bow tie, especially with triangles. So whenever we have this bow tie shape, we need to know that those angles that are directly across from each other are going to be congruent to one another. I should probably label my triangles here. So P, Q, R, S, and T, right? So for us, from this picture, we would gather that PRQ, so angle PRQ, is congruent to angle TRS. Okay, so that's what we would be pulling from there. Again, I had to use 3 letters because angle R would be naming both of them. So we have to know specifically which order we're talking about. Lastly is this shared side. Now I want to make sure we're understanding the word behind it, and I would rather you use the word reflexive because this is the formal property name. But shared side is a way for us to remember reflexive. Okay, it is known as the reflexive property, and this is when a side is common in both triangles. Okay, and they don't normally give this one to us. This is one that we normally have to pick out from the picture. Okay, so it might look like this. Okay, A, B, C, D. Okay, and we can see that line BC, right, is in both triangles. It is in triangle ABC and it is in triangle DBC. So that is a shared side and it is congruent to itself. And we would write that as BC being congruent to BC, right? Being congruent to itself. Another way we might see it is like we saw in that one problem where we had the perpendicular bisector. Let me label this one as well. E, F, G, H. Okay, so right here, F, G would be congruent to itself. So F, G would be congruent to F, G. And again, this is known as the reflexive property. Okay, shorthand shared side, right? Because they're sharing that side. All right, so after this, you're to work on the homework sheet that has some practice on marking the picture. If you have any questions, please feel free to come up and ask.